two passenger trains running in opposite directions at 35 kilometers per hour and 45 kilometers per hour. A boy sitting in the slower train passes the faster train in 8 seconds. Find the length of the faster train. The first thing we are going to do is draw a picture of the situation, and this will be always true when we are trying to solve mathematical problems. Drawing a picture will always help us to understand the relationship between the quantities and the object in the problem, in this case our two trains. Our first train will be moving towards right, and our second train will be moving towards left, opposite directions. Now we can label the trains. Our first one will be A, and is the train in which our boy is. And our second one will be B, our faster train. Now we can write down the information given to us in the problem. The velocity of A, 36 kilometers per hour. The velocity of B, 45 kilometers per hour. And the time, which is 8 seconds. Now the problem is asking us to find the length of the faster train, in this case B, or this small distance. Notice that we have different units of measurement in the velocities and in the time, so we have to convert kilometers per hour to meters per second by multiplying conversion factors to change the units. So our first conversion factor is 1 hour, equivalent to 3,600 seconds, and our second conversion factor, 1 kilometer, is equivalent to 1,000 meters. Now we can cancel hours with hours, kilometers with kilometers, and some of the zeros to simplify our calculations. Now all we have left in the numerator is 360 meters and 36 seconds in the denominator. 360 over 36 is just 10 meters over seconds, of course. Now we can do the same to our velocity v. 45 kilometers per hour, and we are going to multiply by our first conversion factor, 1 hour, equivalent to 3,600 seconds. Now we can multiply to our second conversion factor, 1 kilometer, equivalent to 1,000 meters. Same as before, we can cancel hours with hours, kilometers with kilometers, and some of the zeros to simplify our calculations. So in the numerator we're left with 4050 meters, and yet again 36 seconds in the denominator. 4050 over 36 is just 15 meters over seconds, of course. And notice that our trains are going towards each other, which means that the velocity our boy is going to perceive will be the sum of the velocities of the trains. And that's the velocity we are going to use to find the length of our train V. So 10 meters over second plus 15 meters over second, that's just 25 meters over second. And the length of V, or the distance, is just velocity times time. And our velocity is 25 meters over second, whereas our time is 8 seconds. So we can cancel seconds with seconds. We have 8 times 25 meters, which is 200 meters.